10 at 5. So as usual, another wee starter here. I want you to complete the starter, pause the video, do the starter, and then unpause it because I'm just about to go over the answers. So question 1. What happens to the H plus ion concentration when acid is diluted? H plus ions, if we're diluting it, they decrease. Okay, and just a wee sort of side note, you never had to write this, but the pH, because it's an acid, it goes up towards 7. Okay. Question 2, name the 3 types of bases. We learned that last lesson. The first one is a metal oxide. Second one is a metal hydroxide. And then the last one is a metal carbonate. Okay. Question, you need to know those 3 bases, yeah. You have to be able to recognise them. And question 3, in terms of pH, what happens to the water? What happens to water when the following substances are placed in water? Okay, so what happens to sulfur dioxide? Now, you need to recognise that that's a non-metal oxide, yeah? And you should know that when non-metal oxides dissolve in water, they form acids. So if we dissolve sulfur dioxide into water, the pH is going to be less than 7. And remember, sulfur dioxide, that's one of your acid gases. Yeah, that, carbon dioxide. Calcium oxide, wee bit different. This is a metal oxide, so it's a base. Yeah, metal oxide, calcium oxide. So we need to use our data booklet for that. So if we go to calcium oxide, that's soluble in water. Okay, so it will dissolve. So that tells us that the pH, because it's a metal oxide, the pH is going to be greater than 7. Yeah, it's going to become an alkali. And then nickel oxide, again, it's a base, it's a metal oxide, like calcium oxide. However, if you go to your data booklet, nickel oxide is insoluble. Okay, so it doesn't dissolve in water. So what that tells us, if it doesn't dissolve in water, the pH is going to remain 7. Okay, so remember how to work that out. Non-metal oxides give acids when they dissolve in water. Metal oxides give alkalis when they dissolve in water. Okay, if they can't dissolve, nothing happens to the pH. And then question 4, starting with lithium, show how an alkali could be made. Okay, so what you need to do is you need to create a base. So what we do is we burn lithium and oxygen, and that will give us lithium oxide. Okay, we then take that lithium oxide and we dissolve it in water, and that there is going to give us our alkali, which in this case will be lithium hydroxide. Okay, so that's our alkali. And that's how you do that. Yeah? Again, you need to know that. So important. Right. So our heading today, lesson 4 of acids and bases, is neutralization. Okay, now we spoke about neutralization briefly in previous lessons, but we're going to go into it in a lot more detail. Now, you would have done this in second year. However, I'm going to start from the basics, and the first thing we need to know is the definition. What is neutralization? Okay, now, definition. It's when an acid reacts with a base to form 2 neutral products Okay, and those two neutral products you should know from second year, but don't worry if you've forgotten. You get a salt and you get water. Okay, so you need to know that. Now, what you know, you should know that acids have a pH of less than 7. Yeah, we've done that. That was the very first lesson that we did. So acids have a pH less than 7. So during neutralization, the acid becomes neutralized when its pH is raised to 7. Okay, you could also put in brackets or above. So what happens is we add a base to an acid, the pH of the acid will go up, it will go to 7, it becomes neutralised. But if we keep adding more base, if we keep adding more alkali, then what happens is that the pH will keep going above 7 because we're adding more of the alkali. Okay? Now, again, we spoke about this last lesson. You need to know this. Substances that neutralise acids are called bases. Okay? That's what we mean by a base. Anything that can neutralise an acid is called a base. And you need to know your three bases. Obviously your metal oxide, metal hydroxide and metal carbonate. Now, there are 3 types of neutralization reactions. And we, not this lesson, but over the course of the next 2 lessons, we are going to look at all 3. So the first one is going to be an acid plus a metal hydroxide. Okay, metal hydroxide be an alkali. So that's our first one. Our second one we'll look at will be an acid plus a metal oxide. Okay, and then the last one, probably be able to work this out, is an acid plus a metal carbonate. Okay, so we're going to look at how the 3 bases, metal oxides, metal hydroxides, metal carbonates, can neutralise acids. Okay, so the first one we are going to look at is your acid and alkali. Okay, so the metal hydroxide we're going to use an example of. Now, the reaction, and you need to know this off by heart. Now, it's quite straightforward because it's exactly the same as the second year one. So, it's an acid plus an alkali, and that gives us 2 products which you should already know, salt plus water. Okay, and they are both neutral. That's why it's called neutralization, because we're taking an acid and alkali and we're neutralizing them. We're making them become a pH of 7 in the form of a salt and water. So an example would be if we take the acid hydrochloric. Yeah, so we take hydrochloric acid, we react that with sodium hydroxide, and that gives us the salt, sodium chloride plus water. Okay, now what we're going to do this lesson as well, we're going to look at how we name the salt. Okay, Now, looking at this hydrochloric acid and sodium hydroxide, we're getting sodium chloride. I want you to have a wee think about how we named that salt based on these two, okay? But we will come back to that, don't worry. Now, another reaction, yeah, just call that reaction A, call that reaction B. Just to give you another example, if we take sulfuric acid, okay, we react that with, say, potassium hydroxide. That's going to give us potassium sulfate, which is our salt, and as usual, we're always going to get water, okay? And again, we're going to look at how do we name that salt. I used potassium hydroxide and sulfuric acid. How did we get potassium sulfate from that? So have a wee think. Right. So what we're going to look at, we're going to look at the salts. Okay, that's what we're interested in this lesson, is the salts. Now, there are many salts, okay? There are many different salts, okay? Not just sodium chloride. Okay, and some of you will probably know sodium chloride is table salt. That's what you put on your chips. Okay, that's not the only salt that there is. There's many different types of salt. Sodium chloride is just the one, the one that we use. Now, a salt, basically all that is any neutral, okay, and that's key there, any neutral compound formed with water in a neutralization reaction. Okay, so any neutral compound that we get along with water in a neutralization reaction, we can call that a salt. It doesn't always have to be sodium chloride, as we saw with potassium sulfate. Now, this next part, very important, okay, and this will help us understand exactly what's going on. Okay, so what happens is the H plus ion of the acid and the OH minus, the hydroxide ion of the base join together to form water, okay, which is H2O. So we're adding H plus to OH minus, and that gives us H2O to form H2O. And what happens? The remaining ions form the salt. Okay, so an example. Yeah, there's a few examples here. Let's look at the first one that we did with HCl. Okay, with hydrochloric acid. Now I'm going to write out the formula for that. So hydrochloric acid, you should know, is HCl. We're going to react that with sodium hydroxide, which is NaOH, and then that forms, okay, two products. Now, what happens? Like what I said here, the H plus ion of the acid and the OH minus ion of the base join together. So what happens? That H of the acid and the OH of the negative, what happens is that we add them together, and if we add them together, what we're going to get is we're going to get H2O. We're going to get water. Okay? Now, then what I said, the remaining ions form the salt. Okay, so we take the HCl, we take the sodium, they join together to form sodium chloride. And that's it. Okay, that's what's happening there. Yeah? Now, if I go for, if I call that reaction 1, let's go for reaction 2. Let's go for sulfuric acid, so H2SO4. And again, you should know how to write the formula for sulfuric acid, H2SO4. We're going to add that to lithium hydroxide, okay, and we're going to get two products. Again, what happens is the H, doesn't matter if it's H2, just the H of the acid and the OH of the base, they react together to form H2O. Yeah? And then all that happens is that the remaining ions, yeah, the lithium and sulfate, they join together to form lithium sulfate. Now, the reason that's Li2SO4 is that if you did SVSSF with lithium and sulfate, you would get Li2SO4. Okay. Now, I'm not going to balance this reaction. You could balance it, but I'm not going to, because that's not the purpose of the lesson. Now, if I just do one more, okay, we'll go back to hydrochloric acid, so HCl, we'll add that to ammonium hydroxide, and again, we're going to get two products, and the same thing happens. Yeah, the H of the acid and the OH of the base, they add together and they give us water. Yeah, every single time that happens. And then the remaining ions, the Cl and the NH4, they react together to give us NH4Cl, ammonium chloride. Okay? And that's it. Now, we're not going to do this now, but there's a thing called spectator ions where ions cancel out, but we're not going to look at that just yet. What you need to know is that the general equation for an acid plus an alkali, okay, is this here, is H plus OH minus goes to water. That there is the neutralization. Yeah, that's the neutralization for when we add, the neutralization equation for when we add H plus and OH minus ions, when we add an acid to an alkali. Okay? So that is the neutralization reaction for an acid plus a metal hydroxide if it's an alkali. Yeah? So H plus OH minus H2O, and you need to know. Okay? Need to know. Right. The last thing we're going to do this lesson is naming salts. Okay, I did say we were going to come on to this. You probably already worked it out already, but we're going to go over it now. To name a salt. Okay, so the beginning of the name comes from the start of the base and the name ending comes from the alkali. Now that might not make sense just yet, but I'll show you what I mean. Now if we look at the acids, okay, so we've got acid. Now there are a few acids, obviously we'll write them. We've got hydrochloric acid, we've got sulfuric acid, and we've got nitric acid. Okay, that's the three acids that I told you need to remember off by heart. Yeah, HCl, H2SO4, HNO3. Now there is another one. You don't need to know the formula for this one or that, but phosphoric acid. Okay, now what happens depending on what acid you use alters the name ending of the salt. Okay, now you might have already picked this up, but if we use hydrochloric acid, the name ending of the salt is chloride. Okay, if it's sulfuric, the name ending of the salt is sulfate. If it's nitric, the name ending of the salt is nitrate. And phosphoric acid, the name ending of the salt will be phosphate. Okay, so what we do is we take the beginning name comes from the start of the base, and then depending on what acid we use depends on the name ending of the salt. Now the best way to do this is just to give you examples. Yeah, so if we use sodium hydroxide and sulfuric acid, okay, hopefully you see sodium hydroxide, that's a metal hydroxide, so that's the base. Sulfuric acid, obviously, of course, is the acid. Okay, so if we look at our the beginning of the name of the salt comes from the start of the base. Okay, now the start of the base is sodium. So the start of the salt is sodium. And then the acid, depending on what acid we use, determines the name ending of the salt. So sulfuric acid, it would be sulfate. So the salt becomes sodium sulfate. And that is it. Okay, obviously plus water because it's neutralisation, but the salt is sodium sulfate. Yeah. Now I'll do two more, and then I'll give you some to do on your own. Let's go for copper carbonate plus hydrochloric acid. Now again, hopefully you recognise that that's the base because it's a metal carbonate, and then hydrochloric acid, of course, is the acid. So again, we take the first name of the base, which is copper, and hydrochloric acid, if we look at our table, hydrochloric acid, it converts into chloride. So this becomes copper chloride. And of course, we are going to get water as well. We would also get another product, carbon dioxide, because we've used a carbonate, but don't worry about that. Don't worry about that just yet. I'm going to go into that in the next lesson, so don't panic about that. Right, third one, Let's go for zinc, oxide, and phosphoric acid. Okay. Again, the metal oxide is our base. Okay. The phosphoric acid is of course our acid, and that again we take the first name of the base, zinc. Yeah, so it doesn't matter what type of base you use, whether it's a hydroxide, carbonate, or an oxide. Okay, it's always the metal part of that, so it's zinc. And then phosphoric acid, the name ending becomes phosphate, so this salt becomes zinc phosphate plus water. Okay, now what's going to happen is I'll do 2 questions for you guys, see how we get on. So I just want you to name the salt formed. So the first one, we're going to go for lithium hydroxide plus sulfuric acid. Okay, I want you to name the salt. The next one, go for nitric acid plus magnesium oxide. Name the salt, and then we'll do the last one. Go for hydrochloric acid plus ammonium carbonate. Okay, so what I'd like you to do, pause the video, do those questions, and then we'll come back to it. So, lithium hydroxide plus sulfuric acid. Again, what you do, identify the base and then take the first name of that. So it becomes lithium. In fact, I'll maybe just write my answers down here, give me more space. So A, lithium, and it's sulfuric acid, and if we go back to our table, sulfuric acid, it should be sulfate. So the salt here would be lithium sulfate. So well done if you got that. B, again, you've got to identify the base. So in this case, the base is magnesium oxide. So it's the first name of the base, magnesium. And nitric acid goes to nitrate. So this is magnesium nitrate. Yeah. C, hydrochloric acid plus ammonium carbonate. So the base is the carbonate. So take the first name of the base, which is ammonium. And we're using hydrochloric acid. Hydrochloric acid, the name changes to chloride. So this salt is called ammonium chloride. Yeah, and that is it. So let's summarise this. So you need to know the definition of neutralisation. Okay, so when an acid reacts with a base to form 2 neutral products, a salt plus water. Yeah. Now remember, substances that neutralise acids are called bases. There are 3 types of neutralisation reactions, and you need to know them. Yeah, an acid plus a metal hydroxide, an acid plus a metal oxide, and an acid plus a metal carbonate. Okay, you need to know them. Now the first one, we'll look at the other two types on the next lesson. We just looked at an acid plus an alkali, well, metal hydroxide in this case, okay? So you need to know this equation. An acid plus an alkali gives you two products, salt plus water, okay? Make sure you understand that. Hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. What's important is that you're able to name that salt, okay? Yeah, so take the first name of the base and then change the acid. You need to know why we're producing a salt, why we're producing water. Okay, so remember what we said here: the H plus ion and the OH minus ion react together to give us water, and then the two ions that are left react together to give us the salt. Okay, the general equation for an acid plus an alkali is H plus OH minus gives us H2O. So it's a hydrogen ion plus a hydroxide ion gives us water, and that's our neutralization. You need to know that, okay? Need to know that. And then the next part was all about naming salts. Okay, so take the first name of the base, change the acid, and that's how you get the salt, sodium sulfate. Yeah, make sure you know how to do that. Right, that'll be us for today. Thank you.